Thanks, Avik. Hope you had a refreshing break. Another opportunity to interact with the Aerospike experts out there at the booth. My name is Vikranth Dharamshi. I'm a sales engineer at Aerospike. I work with a lot of you out there, APAC customers, day in, day out. Graph solutions are a key for uncovering relationships across diverse data sets. And when we did this poll some time back, you notice there is good demand for graph out there, which is what I'm going to talk about to you today. Graph database is all about intuitively modeling complex networks of these complex interconnections between data, and then representing it in a machine-readable form and have the ability to query that easily through an application, and also have the ability to update this constantly as we go ahead and the diverse data sets that we come across evolve. So in this presentation, I'm going to talk to you about the Aerospike's newest graph offering, which is massively scalable, developer-ready, and real-time out there. So I'm going to talk to you about Aerospike features, graph features, how we compare against other offerings out there in the market. We'll look at some real-time property graphs out there, some examples of it, what actually constitutes it, what value you get out of it. We'll look at the Aerospike Graph Services architecture out there, how it is built, what are the underlying components around it. Finally, look at some quotes that have come from prospective customers who are evaluating Aerospike. And then finally, we'll have some time towards the end for Q&A. And if you still have questions in your mind, you can always go back to the booth. You'll find me or my colleagues out there to help you out with your questions, not only on Aerospike Graph database offering, but Aerospike on the whole out there. So without further ado, let's get going on this. You would have experienced this. Graphs are out there every day in our lives. Social networks, LinkedIn, Facebook, while you're booking your travel bookings, routes, recommendations engine, when you're trying to purchase something on retail portals out there, graph databases all around it. Okay? For a long period of time, traditional databases like RDBMS or other new age databases have been trying to model this data and get you these insights. But over a period of time, as these interconnection complexities have increased, and also the ways at the frequency at which you're going to update and you want to derive analysis out of it, those solutions fall short out of it. And that's where you require a fully scalable, real-time graph solution out there. If you look at some of the statistics which were done by some analyst firms like Gartner, somewhere around year 2021, popularity and adoption of graph databases was around 10%. And we looked at it in the polls also that we did. But in the year 2025, there is projection that will go up by, up to around 80% as we go ahead. So let's dive into this and try to understand how a graph database kind of supports the statistics out there. So let's try to understand a real-time property graph and the use cases around it. What actually constitutes a real-time property graph out there? The value proposition of real-time property graphs lies in its ability to provide insights, analysis of complex relationships in real time out there. So if you consider some examples, for example, an identity graph for the advertising technology industry, where you try to use this to do targeted advertising, real-time bidding. If we shift to another universal use case, something like a customer 360, again very common across multiple industry verticals like telecom, e-commerce, real-time property graphs play a role out there. They can help organizations to decipher this complex network of data interconnections. If you take it further to other use cases, you have fraud detection, recommendation engines, again, applicability in various industries like financial services, e-commerce, retail, etc. Why this matters is because real-time graphs provide the ability to process complex data. In real time, you get the contextual understanding, handle large data sets out there with these complex interconnections, predict outcomes, and enhance the ultimate visualization that comes out of it. So let's pick up one of these examples, which is an identity graph, which requires a highly scalable, low latency, real-time property graph out there. So let's try to understand what is an identity graph. Okay? So I'll try to explain this to you in the next slide through an example. But an identity graph provides you a single unified view where you're trying to, it could be of customers or various products or services that are offered by your companies, where you try to tie these entities together, understand the interactions that are happening around them, could be through various channels, devices that you use, and you try to form this mesh around this. So let me show you an example of how to use an identity graph with a household example. Members in a household who are watching a streaming service on television, which they purchase using various payment mechanisms. Let's take cars, for example. So in this example, we have the Jones household. It's got 3 members out there. They all kind of subscribe to a streaming service. Each family member, you can track what he's watched, which channel he's watched, and what movies he's gone through. What payment mechanisms has he used to actually subscribe to these services out there? And the next thing, what devices he's actually used to watch these streaming services. Okay? Now in this, Mr. Jones actually goes out on a business trip, and then he uses his corporate credit card, which is not known in this graph solution at this point, okay, in this data set that you have, and he watches a movie on a streaming service in his hotel room. Okay? So what's new out here? But he watches this on his personal laptop. What is new out here which was not known in this graph data set earlier? One is his corporate credit card was not known, and then the IP address of the hotel where he stayed, and of course, what did he watch? Was it something new apart from the preferences that he's already been watching earlier? But the common thing over here is his personal laptop. So with that, they are able to link that it is actually Mr. Jones 2 is not Mr. Jones 2, he is the original Jones. Once they merge this new data that came in into the existing interconnected graph data set, they were able to figure out that Mr. Jones 2 is actually Mr. Jones, and he has used a new credit card to subscribe to a streaming service in a particular hotel, and probably he's watched something apart from his usual watching preferences. So this is the kind of challenge or challenges a graph technology can help you solve. So you got an initial data set, then you keep tracking the interactions or purchases across various channels and keep enriching that data set to derive the kind of insights what you saw out here. So all you need to add in the existing graph data set that we did is we added this new set of information to the known facts we have about the household. So there are 3 people, they use an X set of credit cards, they watch certain set of streaming services, they've used X set of devices, but we found out new relationships over there, which is his new credit card, his watching preferences. So you got to know about his new credit card, the hotel he's visited, which kind of helps organizations to target their marketing spends in the right direction, make sure they address the needs or the leads that are come out in order to put in the right marketing content to the customer, and in turn give the customer a better experience. So this is an example of what we call as a real-time property graph. In that category, it is identity graph, one of them for which Aerospike Graph is really well suited. So let's look at Aerospike Graph in a little more detail. We see a huge opportunity for Aerospike to address this market, especially because the current offerings in the market, they have scale limitations. They struggle with latencies out there, especially when you're dealing with these complex relationships and traversing through that, and struggle with addressing high throughput out there. And some of the reasons for that is existing solutions are in-memory based, where you try to load the entire graph out there, and your ability in terms of how much of graph data you can load is bound by the amount of memory that you have in the cluster. So that kind of restricts you and your ability to grow and analyze a larger data set out there. There's another flavor out there of custom implementations, which over a period of time are very inflexible, complex to maintain, add on a large amount of technical debt to kind of manage them, maintain them, and continue to derive value out of it. Here is where Aerospike steps in, where there's a dire need for a high performance graph database that can scale to trillions of edges or vertices and associated edges with that, deliver that predictable low latencies that are required to make the kind of real-time decisions that we saw with the Jones household earlier, handle extreme query throughput because more and more people are going digital out there. What better example of it than what is happening in India right now? So here is a quote from our CEO Subbu. A couple of months back when we went GA with our Aerospike Graph offering. I leave it there for a few seconds for you to go through it. Aerospike, like its original database what we had, we are committed to provide our customers with real-time solutions, best performance, scale, and we try to do all of this at an extremely low total cost of ownership. So let's move to the technical aspects of the Aerospike platform architecture. We'll decipher each of these pillars one by one as I take you through it. One, Aerospike Graph is massively scalable. So if I put some quantifying numbers on it, you are future-proofed in terms of storing billions of vertices, trillions of edges that come out of it and connect each other. You can scale compute and storage layer independently. I'll touch upon that in a little more detail as I go ahead. You get real-time OLTP performance out of it. Let me explain like a OLTP OLAP in the graph scenario. So OLTP we have kind of seen in our identity graph, Jones household example. You want to understand that new relationships that come in or decipher your existing relationships in real time. That is OLTP. But if you look at OLAP, you would probably need, a few minutes are fine, or you want to do it in a batch mode, offline mode. That is where the graph OLAP databases come in. So the current offering of Aerospike that we have built is more suited, catered to the real-time OLTP graph performance. You get a native graph query language interface around it where developers can use it to run your graph queries in a business-friendly way, easy to understand, easy to write those queries. Rather, when you compare it against when you try to custom build it and build a query language of how you access that, which is nothing but Gremlin. Over and above that, we have also built, understanding that these data sets that you get are going to come from various data sources. It's not going to just come from one place. You will have to read it from multiple data sources, ingest it into Aerospike Graph database. Right? So you need a very efficient bulk loading tool out there is something what we have built and offering it, which is built on Spark, where you get the ability to bulk load data into your Aerospike Graph database, again in real time or batches, whatever is the requirement or the pace at which your sources are going to spill out that data. So you get that great amount of flexibility. And the final thing is the operational efficiency. You're using the same database, and in the previous poll we noticed we put out some popular data models out there. Aerospike is gearing up to support or be a multimodal database to support key value, ability to store JSON documents in Aerospike, and in that multimodal journey, the same database is also able to offer a graph solution to you. And we do this with a significantly reduced TCO. So in the larger scheme of things, if you look at that top block where Aerospike graph is highlighted in yellow, that's a multimodal journey. We started off with key value. Now we give you the ability to store JSON documents. On that journey, the next step, we've got graph. You heard Subbu speaking in the morning. We're going to come up with vectors soon. So that multimodal journey continues where you can use the same database to support these various data models. Let's dive into the Aerospike graph architecture. So on the left-hand side are your various applications that are going to use a native graph query language, Gremlin, where you fire queries. And then we have this graph service layer in between, which is built on the framework of Apache Tinkerpop, which is the graph computing framework. This is a layer which kind of handles the first set of throughput that comes in. And then towards the end, where you actually store your interconnections, complex networks, is all in the good old Aerospike database. So over here, the aspect that you need to kind of understand is these two layers are separate. Okay, they are independent of each other. And let's say your workload requires you to run high throughput queries, but the amount of data set, the graph data set that you have is pretty much the same. Don't scale your storage. You can scale only your graph compute nodes to handle the high throughput. A lot of solutions out there in the market do not have this ability because both those layers are fused. So you get this ability where you can scale up individually. Your throughput is still the same, but you're storing more and more graph data out there, then just scale up the Aerospike database. So you get a great amount of flexibility with this architecture to scale up that specific layer, what is relevant for your workload. So if I map these benefits to a lot of offerings that are out there in the market, so Aerospike graph database, because of its independently scalable graph compute and the storage layer, gives you great TCO advantages against a lot of peers that are there in the market, competition in the market. There are a few names that are put out there, and with our internal benchmarks, these are the kind of numbers we have seen. And the fundamental reason for that is the architecture that sits behind Aerospike graph database service, which is individual compute and storage layers. You get unparalleled scalability and data throughput because of that individually scaled layers, predictable low latency, extreme throughput, optimized for transactional workloads. So with this nutshell, with all these features, which are again aligned with the 4 key tenets of Aerospike, which we have always had and we stand by, you get these kind of advantages with competition out there in the market in terms of TCO, performance, in terms of the throughput that can be handled, predictable low latencies, etc. So let's look at some of these benchmarks that we have run internally on not only on bare metal servers but also on cloud instances. We have specified the cloud instances also what was used for the individual graph compute layer and the storage layers. So if you're trying to do a one-hop query in the graph terminology is you land on a starting find the vertex or land on a starting vertex, and then you traverse the surrounding neighborhood around it. That's a one-hop query, and our benchmarks show that Aerospike graph database is able to offer that in under a millisecond. Next, if you go to a little complex query of reads in the graph world, 2-hop queries, find a vertex and traverse to 2 additional hops around it, and then traverse the attributes of the vertex or the next edge and the attributes around that under 3 milliseconds. You try to perform a simple update where you're dealing with a single vertex and some edges around it under 5 milliseconds. A complex update. So this kind of aligns with what a real-time property graph needs, which is real-time performance out there. And look at the kind of QPS we are able to support, 60K, and we have even In the latest benchmarks, we have hit around 100K TPS graph queries that you run, and you're able to get this kind of performance out of it. Right. Towards the end, this is one of the quotes given by a prospect of Aerospike who's currently evaluating. Again, standing by those key tenets of Aerospike database, moving on to the Aerospike graph, real-time, low latency, cost optimized, all those features kind of standing out in this code. So in summary, Aerospike graph, massively scalable graph database for real-time performance for OLTP graph queries, graph native query language support in the form of Gremlin, with a very efficient bulk loading tool, kind of taking away the complexities of how I talk to various data sources and get my graph data into Aerospike graph database. And you do all of this at operationally cost efficient, low TCO out there. So that's all I want to tell you about the Aerospike graph database today. Open for questions. Somebody there?
In one of your slides, you have shown about real-time OLTP, right?
Yes.
Graph database. How about OLAP as such?
Right. Great question from your side. That's the reason I kind of dived into a little bit of detail also how we categorize OLTP and OLAP. At this point, the release that we have built is more focused towards real-time property graphs. And over a period of time, we're going to enhance that and come out with support for OLAP also in the works.
Okay, thank you.
That's the kind of thought process around it.
So it's evolving as such?
It's going to be an evolving thing. This is the first release that we have brought out, which is targeted to a set of use cases that I described, which are more focused on real-time property graphs, identity graphs, which falls in the OLTP category.
Okay, yeah. Thank you.
Yeah, there's one at the end there.
Just a query about last month, the Government of India passed this data protection bill. How it will impact, like you are sharing someone data, how it will impact your business?
So when a business actually collects data from your side, from a data privacy and data sovereignty, there are certain guidelines that are given by the government or various regulatory bodies that deal with a specific industry. So as an organization, if you're going to adopt a graph database, you will have to kind of check out your graph database sources. What is actually going to feed to that? Is it data that is coming from within your organization but through various touch points? You're good because your organization is anyways complied. If it is coming from other sources, you will have to probably evaluate that, not only your internal data but the external data, and see if that fits the regulatory guidelines. See, what we are providing is a graph database storage engine. What you store in that is kind of the organization's prerogative and whether it aligns with the guidelines in terms of data privacy, data sovereignty. We give you tools or features within our product to help you with that. For example, encryption or encryption in transit and aspects like that. But what you store is something what you'll have to decide on. Okay? This.
This is Murli here. I have a question related to what the reply that you gave just now. Is this GDPR compliant or some of those standards that we have for security?
Like I explained right earlier, so we give you the ability to store the data in the graph database or in our original key value data store or the document data store. What you store in that or through the application, that you store is something you'll have to comply with GDPR on a larger aspect. Okay. So, GDPR, few of the rules are you give clear visibility to the user what data you have stored about him, and then you also give him the ability to delete that, right. So, as a database we give you the ability to read, write, delete. Now, what your application does and how it is presented to the user is something as an application and database together you will have to deal with that. There was a question
I
here.
have a question. So is the graph database completely a different product, or it's a part of a release, or I mean, are the underlying platforms what are used in graph similar is what in used in the Aerospike base code? So do they leverage each other? Like, that's what I want to understand.
Yeah, great question out there. So if you recollect the Aerospike graph architecture slide that I presented, we are kind of reusing our Aerospike key value storage engine, the database that is actually being used at Myntra right now. The graph compute layer that sits in front, which basically gives you the ability to write gremlin queries from your application, decipher that and fetch that data from Aerospike is what is newly built. Okay. But where the data is stored is the original Aerospike database itself. But the compute layer in front, which has the ability to decipher the gremlin queries and accordingly fetch that data, is what has been built. Of course, the way we model it internally is more suited to what we do for graph, but we have again used the same features that are available in our Aerospike database.
So that is a different product which a customer needs to buy, right? That middle layer.
That's correct. That's correct. Okay. The middle layer is additional, and whatever the data you store in that.
Thank you.
All right. Any other questions? I think there's one more here. I'll take this one, and then if there are further ones, you can reach out to me at the booth outside.
Yeah, Vikranth, hi, it's a wonderful presentation. So just touching upon the historical context of it, back in like 1960s, this codicil guideline came up. And
what guideline? I didn't catch that.
Codicil. So
Okay.
that was around the graph databases and usage of that. And initially everybody thought that graph would lead it because of the multi kind of
interconnectedness of
yeah,
data?
multi-interconnectedness of it, but it slowly, maybe, I'm just trying to ask, so maybe because of the lack of compute power, unavailability at that point of time, it died out. Slowly SQL won the race, and then recent times, maybe back from 2005 to 10, we saw NoSQL picking up, right?
Right.
And I think now, I thought maybe the graph thing has died out, but you showed a slide where you are showing back next year, by next 2 years, there would be 80% overall coverage of.
So when I say 80%, it's not going to just wipe out 80% of the databases and convert that as graph. Basically, the adoption of graph is going to increase by another additional 80% from what we are right now. And in one of the slides also I mentioned, traditionally we have tried to store this data in traditional RDBMS, in other databases like the new age NoSQL databases of other flavors, but you're trying to form this interconnectedness is what you're trying to build through your application, or you're trying to do a foreign key, primary key in your relational database, or you're trying to model it in a key value store out there. But now you're getting the graph database, what it helps is, it lets you store the data directly. You just present it in a graph format, it stores it. You don't have to worry about doing that interconnectedness. And then also gives you the ability to, with a query language where you can intuitively query it. Earlier you had to figure out how do I connect it, how do I query it with whatever SQL gave you.
Yeah,
but
so
now you're getting a query language which is very, very suitable for this kind of access pattern.
Yeah, the data model transformation is not required, essentially. We can exactly store in a way.
Yes, not a lot of it. Or stitching the data together is not required. Otherwise, such a data model database wouldn't have come, because you're struggling with the scale, the interconnectedness, etc.
Yeah, so I think the latency number that you showed, those are very impressive. If those could be achieved, there would definitely be spike in usage, I believe.
Yes, I mean, this is what we have come across in our benchmarks, and you would have heard in the morning also from Subbu, Srini, Aerospike stands by those 4 key tenets: low latency, high availability, lower TCO, unlimited scale. So whatever new we build, we try to align with that. So that's something what we're trying to do in the graph database also, best of breed in the market.
Thank you.
All right. Thank you, everybody. Any further questions, you can reach out to us at the booth. Thank you.